presentation. And what is important is that I was listening to the lady from Taiwan, professor, saying that she traveled for over 30 hours. Yes, I feel her because that's our experience as well. But obviously I traveled to Poland first last week, then Amsterdam, and now I'm here. So I've really been on a travel journey, and I must say that throughout that travel journey, I also integrated some academic work as well. So I think what is really important when we start speaking about community engagement and really what it is that we are speaking to, I will take you through that just now. But I think what we can do at this point is just go through. So this presentation that I'm talking to you about, it speaks about learning, sharing, and growing. Now, somebody could say, why are you using those three words? Learning, sharing, and growing. And I think when we work with, and I'm emphasizing the word with, when we work with communities, no matter who those communities are, where they are based, what their particular focus is, but when we within our university are working with communities, on campus, off campus, we need to consider that throughout that engagement, and the word engagement has been used so extensively today that I'm so excited about it, because it's in that engagement, that intense engagement, that the learning, sharing, and growing takes place extensively. So here, just looking at within community engagement, which is a sector that I am responsible for, we really have a number of initiatives. I could tell you we probably have over 16 different types of initiatives, whether they are 1 hour long, 3 days long, 2 years long, no matter what it is engagement with our communities. And what we have to think about is, when we are working with these, we have to think, how are we going to be planning it, and how are we going to be presenting it? And remember, the three words that we are working with is learning, sharing, and growing. So in looking at just 3 examples that we're going to be working with, within the School of Education, that's where I'm from, it is important that we consider that the 3 examples are really looking at teacher professional development. And they are all underpinned by the SDGs. So no matter what we do within our university context with our communities, we really focus on all the SDGs, but I think these are the most important ones. And obviously 4 is really relevant to our context if we're looking at quality, teaching and learning, and quality education that is taking place. And we go on to climate change education, and very importantly in terms of the partnerships. So no matter what type of work we do within the School of Education, partnerships are essentially important. So just to give you an idea with regard to community engagement and the type of meaning that we are using within our particular context. Yes, in South Africa we have policies where all HEIs, that's higher education institutions, are expected to work with community engagement. And every single student should be engaged with communities, but it does not happen. So it's much more than policy. It's also about how do we enact these policies within the various contexts in which we actually find ourselves. So within our School of Education, it's very important that collaboration is being looked at, but even more importantly is the mutually beneficial exchange of knowledge and resources in a context of partnership. So listen to those 3 words: mutually beneficial, knowledge is being exchanged, resources are being exchanged, and there has to be a partnership. So that partnership is the base on which everything else is taking place. And what we have to consider in our context is we have such diverse communities, and our communities could range in size from 2 teachers that we're working with because the focus here is teacher professional development, or it could be 20 teachers that we're working with, or 50, whatever the case may be. And what we have to then consider is economic, cultural, social, and political growth. We cannot have educational growth without political growth. If you think about it, any type of development or any type of policy that is being developed and passed has a political link to it. And we have to then engage our communities on what does it mean to be politicized. And we all know that when we're working with pedagogies and professional development of teachers, Šiauliai is very important with regard to the fact that when you teach a subject, you have to have adequate knowledge of that specific subject. So when we're looking at this, it is important as individuals who are going to be designing courses for teachers and implementing, we have to consider what are the core aspects that need to be considered. And notice I did not say core knowledge, I said core aspects. I loved it that earlier on it was revealed that it wasn't just the knowledge, attitudes and skills that one had to work with, you had to add on other aspects as well. And I think when I go back, I'm going to start saying, maybe we should consider more than the scabs. Scabs is the skills, the knowledge and the values and attitudes. So the implementation of any program should consider the content knowledge, the teaching practice and assessment practices. And what is really even more important is that it has to be locally relevant. If we are going to be designing any programs, so to what extent are these programs going to be enhancing with the teachers, with the learners that the teachers are going to be engaging with? Okay, and then I just want to say that the theory of change is really what we work with, and with regard to this, taking into account the various aspects of the movement or the transition of knowledge from the places where people are to the new knowledge that is being learned. So context, relevance, the individual, the pre-knowledge, the post-knowledge, all those particular aspects need to be considered. Okay, so we start off, so there's 3 professional development programs that I will speak to, and I think I need to speak very fast because we don't have much time. So the one program is referred to as Journeying into STEAM program. Now, if we are going to be working on this program with teachers, and here we were given funding and we were told you've got 100,000 divided by 22 will give you the amount in euros. You've got 100,000, go and design a program for teachers from the high school and teachers from the primary school. No absolute focus. And then we sat together and we said, and you'll notice the partners here, I'm not going to go through all the partners, but you can see that there are 6 partners, all involved in this particular program that we had. And we sat together all online, no face-to-face at all, because this is obviously during COVID times. And we decided on how we were going to plan this particular STEAM program. And you can clearly see that if it is STEAM, then what is the emphases that we are going to be working with regard to the science, technology, engineering, art, and the mathematics as well. And you can see that, excuse me, the partners all in here are from not teachers or education centers only, but they are also from HEI centers, they are also from Enviro centers, as you can see here, the Wildlife and Environmental Association of South Africa. So it was individuals from a wide variety of subject fields. And I think this is the richness of any partnership that we need to be looking at. Imagine if we took everybody who was just science or maths or technology specific, you know, and they're so highly specialized in their particular fields. When you bring all of them together, then there's a lot of controversy over what should be, how it should be, and why it should be. Controversy is good. At the same time, we have to look at what's this creativity that's coming within all of this. I must say that I do not have a lot of visuals. I left my adapter, my South African adapter, in Amsterdam. Nowhere can I find the adapter in the shops here. So my laptop is dead, and I tried to resurrect what I could. Anyway, let's go on. So this particular program, as you can see, it's called Journeying into STEAM. And I think when we also design programs, we have to think of the title of the program. Is it exciting for the teachers to actually read it? Or do we just say STEAM program? And the teachers, okay, Journeying into STEAM. Wow, what will that journey entail? And what is it that I could be learning in this particular process as well? So here are the outcomes for the particular program, and you can quite clearly see it's linked to knowledge, it's linked to the practices, it's linked to reflective aspects that need to be considered, it's linked to the curriculum as well, because if we're working with primary school teachers and high school teachers, then the work that we do with them has to be relevant to the curriculum. At the same time, it's also extending them beyond the curriculum. And notice the fifth one, engage in co-construction of sustainable projects. So this particular program had 3 phases. The phase 1 was when we took the teachers on a 3-day outdoor camp in the Enviro Center, where you've got the beach at one end, you've got an estuary at the other end, you've got a forest at the other end, and the teachers were now engaged in this particular space. And for some of these teachers, they had never ever experienced this type of field trip before. And it was, I haven't given you the full detail of the program, but for the teachers, I mean, we did so many different things with them, and as you can see, inquiry-based teaching and learning, investigations into ecosystems. So we went to the sand dunes and we looked at why do the sand dunes have the height that they have. Let's measure the sand dunes from the actual seashore itself. Let's look at the types of plant growth that's present on the seashore. At what point does the forest actually start? And does the seashore and the plant growth or vegetation actually end and then the forest starts? And then actually getting the teachers to problematize all of this, because it's not just about an understanding of the fauna and the flora that is present, it's also an understanding of the environmental aspects, and then getting them to draw. Draw what you see in front of you. Draw you decide whatever it is that you're going to draw. But there's your canvas, there are the drawing materials, and for the next 2 hours, we are just going to sit and observe and draw. And after that, come together and have a discussion about the particular ecosystem. We also did robotics, unplugged robotics. Now, why do we do robotics unplugged? Because these teachers do not have electricity in their schools. So imagine if we're running a workshop where we've got to say you must have a laptop, you must have electricity, We're wasting our time, we're wasting their time. So we have to understand their context, and we have to also look at the relevance of what it is that they are being exposed to. So obviously there's so much more that I can say about phase one. So the teachers were there, as I said, for 3 days. It was so exciting to watch the teachers playing games. They were running around like young children. Because at night we had a global game that they had to play, and they had to take cards and put the cards on the table and run back to their friends and say, this is the card I have. So there were games that they were playing, and it was like, whew, some teachers were mafuta, fat, but then they were running, and their friends, but yeah, anyway. So phase two was where we went to these 8 schools, and we visited each of the 8 schools to observe the teachers within their own particular context, and to have discussions with them about how they were implementing the work that had been done during the phase one. And it was very interesting that the principals of the schools were really so taken up with this, and that they, in South Africa, if you want to work with schools, you have to go through to the Department of Education, and the manager has to agree, then the circuit manager has to agree, then the subject advisor has to agree, then the principal has to agree. So for a project to come off, you actually have to go through a number of steps. But yeah, we do all that so that we can work with it. And you'll notice that in phase two, obviously it was interaction with the teachers and also the learners. And the learners were exposed to a number of sustainable living technologies, like a solar cooker, a water heater, a rainwater harvester, etc., etc. The third phase was when we had our students who were living in these particular areas going into the schools and to work with the teachers and the learners while they were on holiday and the schools were still in term. So there were 3 phases to all of this, and the phases actually lasted over, I would say, 18 months altogether. Okay, so from that we then looked at, so what are some of the reflections that the teachers had given with regard to this? Must I come to an end, Andris?
No.
Oh, okay.
Just some minutes, please.
Well, that's only the first program, and I've got 2 more, but I will finish up quickly. That's fine. So one of the things that the teachers also learned was the importance of reflections and how to write reflections. So what we were doing was we taught them how you can draw a flower. And as I said, I don't have all the drawings, I just have very few because it's all on my laptop. We taught them how you can draw a flower, and in that flower, actually organize your thinking with regard to what you've learned, why you learned it, what it means to you, and how you are then going to use it in your own teaching and learning with your learners. Okay, so you can quite clearly see here, the STEAM program is a major enhancement for teaching and learning, not just the disciplines in STEAM, but also language, history, and geography. And I think that's what we tend to forget, that when we label something as STEAM, we're actually trying to be exclusive, and yet it is very inclusive. To go here to a school management person, the teams for the extended phase were well planned and organized. The learner groups for the effective facilitation obviously was as well. Only one high school was not prepared, even though they were informed by the subject advisors. So when we went to visit the schools, I cannot tell you how many times I made phone calls. Principal, please, we're coming on this date, you sure you're ready? In the one school we arrived, the principal was leaving and he just waved and said, "See you," and he was gone the whole day. And the whole school didn't even know that we were coming, and yet the principal knew that we were coming. So it's some of the things that we have to think about when we are doing professional development programs within the context itself. And there are a number of challenges that we then have to work with as well. And because we visited the schools just for a day, from 8 o'clock in the morning until 2 o'clock in the afternoon, the whole thing was that this was so important, but one day was not sufficient. So how do you extend it when the funds that you have are limited? So these are the things that we need to think about in the challenges that we experience. And here, I didn't put it, but this is reflections on the school visits themselves. And this came from the teachers, from the management, from the learners within the school, okay? And here, what we also did while we were at the schools is we had a science show. Learners have never been exposed to a science show before. We took books for the learners because reading in South Africa with the PIRLS test that recently was announced in terms of the results, only 18% of our grade 4 learners can read with understanding. It tears me apart. So we have to think that even though we are working with science-related projects and programs, literacy is the seat of all of this that we need to be able to work with. I'll quickly take you through another program. We did a program on climate change education. It was funded by VVOB, and VVOB is doing a lot of work in South Africa. And with regard to the climate change education program, I decided to share with you a reflection from a teacher first. And I think when the teachers start saying, if we as educators can in some way impart awareness on the state of the earth at present to our learners, they will take this knowledge to their communities. Even if they bring about a small change to reduce their carbon footprint, this small change eventually adds up multifold. Now, our reason for working with teachers is that when you work with teachers and you have the intervention program, you have to think about what will be the sustaining aspects that the teachers will continue with the program within their particular schools as well. So if you look at this, if I have in some way inspired my learners to bring about change, then I have succeeded in my role as an educator. So it's also this internal motivation that has to be created when we're working with teachers, because it's not just simply about the teacher attends a program, the teacher completes all the tasks in the program, and then after that, well, I've done it, I've ticked it off. It's about the importance of what they are learning and how they engage their learners in that particular process as well. And here, the climate change, you can quite understand that climate change was a focus on climate change and the fact that it was having an impact on communities, but very few people, teachers, community members actually are aware of climate change. It is within our curriculum in grade 8 and 9 in natural sciences, and it's also in the grade 10 and 11 geography. So we worked with both geography teachers, 20 geography teachers, and 20 natural science teachers. I'm only focusing on the 20 natural science teachers. And what was important here is that these teachers were from one teacher from 20, so it was one teacher per school. We worked at 20 schools, one natural science teacher, one geography teacher, and both of them came to a course that we did totally online. The teachers didn't even know how to use their devices. We had to teach them online how to use the devices because this ran in 2021. Now, with regard to climate change education, we designed the materials, we gave it to teachers to work with, then we implemented the program once the initial trialing of the materials this was a separate group of teachers that we gave it to. They trialed it, they said, no, take that out, put this in, suggest that, whatever. and then we could only use it. So there was co-construction here as well with teachers. And here you can see the teachers worked with the learners, and part of the climate change projects that they had to work with, they decided to do a river cleanup. You can see here, this particular school, they decided that they were going to start up a garden. And this school, they also did a garden, but you can see it was all in pots. Here, what is important is that there was time for the teachers to be together, to discuss their learning as well. So we called it professional learning communities, PLCs. And that is very relevant to the way in which this needs to happen. Yes, I'm coming 2 more minutes and I'll be done, I promise. One, okay, I'll be done. Okay, in one. Then I'll just, so here I just, teachers' responses, Mr. Pilas. This is one of the teachers who spoke about his experience of learning in the climate change program. This is one of the other teachers who also spoke about learning in the program. It's improved her teaching, pedagogy, content knowledge, teaching methods, and her learners' performance improved related to climate change education. She believed that women have been benefited and were empowered from the project within the context of her school. So really what we need to think about is that it doesn't matter what project or program we have, how we design it is important. I will just show you, this is the third one that we did, which is looking at key concepts in science. And when you're teaching about the solar system and looking into space, etc., those are foreign topics for many teachers. So we had to look at how do we work with these particular topics with these teachers. Okay, I'll just go on to the end. We did pre-test, post-test with teachers. We did the analysis. That's where the teachers were actually doing the practicals at university. And in terms of the programs, climate change, key concepts in science, and journeying into STEAM, the teacher professional development programs need essential principles. Their principles need to be that the teachers are totally engaged in the process. They co-construct what is going to be happening. You look at the strategies that need to be used. You look at the content. You look at the assessment as well. And you also look at the change and the reflections that these teachers need to be working with. So the learning, sharing, and growing is really, and I don't use the words progress and success, etc. It's about growing, because growth can be in so many different facets, and we need to consider what those facets are.
Thank you very, very, very much. Just one last applause. Thank you. Thank you too for your really very rich speech and very interesting. Maybe there are questions, please. Later on, discuss individually, please. Yes, because we are a little bit short in time, because other people are also waiting for reports. Now, it's my pleasure to give the floor to my colleague, Małgorzata.
Good afternoon. Let me introduce myself. I'm from Poland. I'm from Kraków, University. But today I represent West Bohemia University in Pilsen. But moment. But our research are from Kraków, from Poland. And how I go the next? Okay. The next 20 years, I'm teaching students chemistry, future teachers, but my last topic is effectiveness of informal and formal education. So today is this topic. Even through formal and non-formal education, it's really available in Europe. Many people still have misconceptions about science. International studies on the correlation between scientific knowledge and non-scientific beliefs concern on the relationship between science and religion, belief on the creationism or Darwinism, or belief in the origin of the universe. Other non-scientific approaches are studies less frequently, for example, chemical versus natural opposition. I talked about it 2 years ago in this conference. Research shows that many people don't believe in the scientific description of the world. It seems that teacher science is not effective. On the other hand, the habits of the everyday life affect our knowledge. So we decided to investigate the effectiveness of science education in Poland. The research converts 3 areas. The first is the effectiveness of school education is transforming in crossing common knowledge into scientific knowledge. The level of knowledge about the phenomena explained during school education was compared with the similar phenomena that were not explained at school. And the third, the durability of knowledge acquired at school was examined and the possibility of changing formal school education during the life of the response, for example, through ads. The research was carried from December 29 to March 22. 472 people were included in the research, and it was participant open lectures in my university. My first university is in Pedagogical University in Krakow. First. In the questionnaire, the response were asked 3 questions about common beliefs about the taste of sugar, salt, and acid. The term salt and sugar in everyday life refer to table salt and food sugar. The term acid appears less frequently, for example, in the case of vinegar or citric acid. However, in chemistry, these compounds attend the all groups. The table salt, food sugar, or acids are only the representative and are not the most difficult. The polycholic curriculum devotes 10 hours to salt, 8 hours to acid, and 4 hours to sugar. It seems that this amount of time should eliminate misconceptions about students about this concept. The respondents were asked 3 questions: is all salt salty, is all acid sour, is all sugar sweet, and after this question we have 3 answers: yes, no, I don't know. And as we can see, it's not very much correct answer, and as we can see, it's a difference between answers about acid and the difference about salt and sweet. Adult responders and Arabic to children, the earlier surveys, we made surveys in 23 about what children think about this topic. We can see that the percent of correct answers obtained for term salt and sugar is clearly lower than the percent of correct answers for the term acid. It's due to the fact that table salt and food sugar are used directly in this form, and the term salt and sugar are written on the packaging. It is different in case acid, and it is in Polish is different because acid in Polish is kwas, but in citric acid we don't say citric kwas, we say citric kwasek. Kwasek means a little acid, so children don't know this word from the everyday life. The statistical calculation in the case of acid refutes the high-zero hypothesis. Therefore, the alternative hypothesis is true. During chemical education, the party belief that all acid tastes sour is replaced with the correct one, not all taste sour. In the case of salt and sugar, we cannot say that. Misconceptions of students have not been displayed in the current course of formal education, and we are looking for the correlation between personal data of responders and correct or incorrect answer, but we don't found. And we only found no correlation between these three questions. So conclusion in the first part of our research. It tested whether chemical familiar to people in everyday lives change their conceptual era from everyday to scientific in the course of education. The obtained result indicates that this change doesn't not take place. Common knowledge of the flavors of popular substance is permanent and blocks scientific knowledge. We can talk here about the phenomenon of negative transfer or productive inhibition. This phenomenon takes place when past experience makes it difficult to master one. This part of research shows that well-established common knowledge is difficult to change as a result of school education. Part second concentrate about acid and term connected with him. And in Polish curriculum we have 8 hours to this topic. The research compared the knowledge of the indicator, red cabbage, known to primary school students, with the indicator known from everyday life, tea, black tea. In Polish, tea it means only black tea, not other type of tea. Hypothesis null is the difference between the answer to the tea and red cabbage questions. We give 4 questions on this topic, to close it and to open. And we can see the comparison answer to question 2 and second. People say that they know why they add acid to indicators with your left hand, but if they must explain this information, you can see that they can't give the correct information. Only 5.3 people of the respondents explained the complete process what was taken. That they know, but they don't know why. Most of the answers are incomplete. There was majority of response wrote one word inside of the explanation. It's very hard to follow this word explanation. It can be said that response overestimate the knowledge. Students' answers were classified in 6 categories, as you see, and we are looking at correlation, and correlation is very low or null, and you can see a correlation between answers of these 4 questions. How conclusion? The level of knowledge about the phenomena explained during school education was compared with similar phenomena that were not explained at school. It was examined whether there was a transfer of knowledge understood as an explication of knowledge accrued at school in real life situation. In this case, we can talk about a very close transfer, because it was examined whether the knowledge of one of the indicators, the cabbage, is used in the similar case. It turned out that the respondents declared that they know how the indicators work, but it is of their skills to explain the process on their own. On the other hand, twice of the many correct answers were obtained in the case of process not included in the school. This calls into question the effectiveness of formal school education. Part 3. In the Polish curriculum, facts as chemical compounds are devoted to only 2 hours. In the Polish curriculum, facts are divided into animal, saturated, and vegetable, unsaturated fats. I know it isn't true, but in our curriculum is that. Students are taught that saturated fat is bad for their health. In chemistry textbook, lard appears among the example of animal fats. This school knowledge is not precise. Lard is an animal fat, but contains more than 57% of unsaturated fats. So we use 2 fats, lard versus cotton oil. Cotton oil also is vegetable fat, contain 87% of saturated A's. Its recent years, cotton oil has been touted as a healthy fat. Recently, there are also publications that negative is claimed. Pupils have two questions, two open questions, and they must say is this fat healthy or not healthy, and they must just give their answers. No hypothesis, there are no difference between the knowledge acquired at school and the knowledge coming from informal education. And here we can see the results. The answer students are divided into 6 categories. I'm looking for time, so I don't speak about these categories. Okay, the next. As shown in figure, as many as 50% of response have incorrect knowledge about lard origin from school. They believe that lard is harmful because it's animal fat and as such is saturated fat. Only 3.4% of the response verified their knowledge and answered correctly. It is different from cotton oil. It is true that a large proportion of response give incorrect answer. It's 1.3. That wrote that cotton oil is healthy oil because it's vegetable oil. So this means it's unsaturated fat. But many people, 15 and 5%, give full correct explanation, very often with a discussion that the sentence of cotton oil have changed several times. And then we answer group into 3 categories: wrong answer, I don't know, and correct answer. And in this case, we can see that in the incorrect answer there is no statistically difference in the correct answers. However, there is a very big difference in case incorrect answer. Therefore, it can be conducted. There is no difference between the knowledge acquired at school and the knowledge derived from informal education. If the response are confident in their school knowledge of animal fat and do not intend to change. It can be said that school knowledge blocks new information. This is and comes from the lapse of psychology, in this case one speaks of proactive inhibition or negative transfer. Conclusion from part 3. It turned out the knowledge about cotton oil, which is not included in the curriculum, is broader and more up-to-date than the knowledge about animal fat acquired at school. The lab results showed how long-lasting knowledge acquired in school can be. It is a pity that in this case the stimulus was generalized and the properties of most animal fats were transferred to lab. It turned out that formal school knowledge does not replace colloquial knowledge of students. It's not stable over time, and often adults have a broader knowledge acquired in adults' life than they acquired in school. Conclusion from whole research. The obtained research shows that school education does not effectively correct the earlier misconception of students. It is no more effective than not formal education and sometimes causes misconception in students. The research shows a large impact of various types of transfer knowledge as archived results. And our knowledge of transfer in education is still very poor because there is little research conducted directly in this field of education. Therefore, this study is discussed. The practical implication from the first part of research seems well established formal knowledge is difficult to change as a result of formal education. It seems that correct scientific knowledge should be introduced as early as possible. In this particular interest, it seems that is a good solution to use name table size of food sugar in formal education, even in kindergarten, to make children aware of the difference between a representative and whole family. In school education, however, there should be to return to the name carbonates from the sugar. The second and third part of research shows that the range of formal knowledge over formal knowledge acquired at school. It seems therefore that formal education should focus more on comprehension related to scientific thinking than on facts that are forgotten. In the first part of the research it also turned out that together related school knowledge blocks future acquisition of knowledge. It seems therefore that teachers should carefully introduce generalization or simplification. It seems that future research should be going into direction. A broader study of knowledge transfer in particular topics and how to teach students how transfer can be used in education. Thank you for the invitation.
Thank you very much. It's a very interesting presentation. Shows that everyday life experience is sometimes very far from scientific life experience. Life is life. Thank you very much. Maybe there are some questions, just one question. You saved a little bit time. No more questions. Yes, but our reporters, they are open to those questions during evening time and so on. Well, next report is coming from our colleagues from South Korea. That's right? Yeah. Sorry? I would like to pronounce your names, but present yourself, please. Otherwise, I will be mistaken. Excuse me.
Hello everyone. Thank you for Andris. Thank you for your time. I am Hyoung-Yong Park. I am a teacher educator for elementary pre-service teachers in Gyeongin University, Gyeongin National University of Education in South Korea. Co-author Hae-Ae Seo is also serves as teacher education in middle school research teachers. We are studying science education and also especially in bioeducation. I am so happy to be here with you in such a beautiful country and a city of one people in the good season. How ice-breaking I prepare this. Thank you for your donation. Where is the Korea? Here. Here. Our country. When you have time, our country is very beautiful like this. Šiauliai. It is. And this is my presentations outline. First, as Dobzhansky said, no life phenomenon can be understood without every evolutionary perspectives. For many scientists and science educators today, evolution is accepted as a unifying paradigm for the life science, and central idea that unifies many single concepts in biology is evolution. In line with this view, national curriculum of many countries propose to cover the evolution as the most important unifying concept in biology. In many studies, has emphasized the importance of an integrative perspective based on the concept of evolution. But although the evolution is a paradigm that unifies the life of science, there is much resistance and controversies to the basic framework of evolution education. Especially in our country, South Korea, there was a petition of the Society of the Division of Evolution theory in textbook. In Korea, Gyeongin, they are the anti-evolution group in Korea. They palliated that campaigning to remove the content of archaeopteryx and post-evolution and evolution of humans, and the basic idea of the Darwin's adaptation of pinches beaks from the habitats. If somebody can remember that the Nature published article about the situation in South Korea, it had made big waves in the Korean science education communities, and I also shocked too. So I then started wondering how non-scientific knowledge like this are constantly being reproduced and spread again. And why the internet and information technology have been developing for several decades. With the development of information technology, learners increasingly rely on online media, such as searching for knowledge through the internet rather than the traditional media. In particular, the influence of information of the internet is expanding, such as online question and answer and encyclopedia service that pursues collective intelligence based on the very high accessibility. Despite its convenience, however, I suspect that this expansion of the internet communication is affecting the scientific perception of the public. So, we set the purpose of the research of this. How the public's understanding of evolution in online spaces differs from the content covered in the life science education. Let's draw the educational indication for the correct understanding of the evolution of life. So the following three programs and research programs was determined as the research questions. Let's analyze the aspects of online writing, the activities related on the evolution. Let's analyze the features of evolution related to post-registered and online knowledge services. Exploring the possibility of automated classification and filtering the evolution-related online postings. Let's talk about methodology. First, let's talk about the target online spaces. There are several search engines in internet portals in South Korea, but Naver is the most popular search engine, about over 55% coverage. Popular. To explore the public understanding of the evolution, the researchers targeted 지식인. 지식 means the knowledge in, and in means the man. So the 지식인 is the intellectual in Korea. As a representative online communicating space, this service supports the exchange of information by asking and answering questions among the users in Korea, like a forum. The service was started in 2022 by Naver. Since it has the largest number of users, much information has been accumulated year by year. However, unlike Wikipedia, the viewers cannot modify it. So the incorrect knowledge is often left unattended. But researchers determined to suspect this internet service. For the target online spaces, we conducted three analyses. For the first question, descriptive content analysis was done. And for the second question, text network analysis. For the third question, how can we distinguish the non-science documents from the internet? AI-based document classification was conducted as this procedure. The sample data was gathered from through the data mining of Q&A service. Over 12,000 and about 4,000 questions and 400 open encyclopedia articles was gathered. using these data, so there was we set randomly 10% of the whole data set, and researchers distinguished documents for three types. Is that scientific contains the scientific knowledge or non-scientific knowledge? It's not related to our interest. The test set was classified by researchers, and the classified document, scientific knowledge document, and unscientific document knowledge are conducted as the data set for the concept network analysis. And finally, we conducted principal component analysis on the training data set. And after that, from the data set, we can make an AI model that can classify all the documents that we gathered. And so, after that, we can classify the all gathered documents by AI models. Let's see the results. First question, the answer for the first question. What is the trend of evolution related to online Q&A activities? Let's see the frequency of the question and answers from the online spaces. Can you see any interesting year or points in the graph? This when they started, and this year, and this year. There was activities that been cycle and bilateral field-wide with recent over trends. The online hosting activity tends to increase around the period of heightened public interest in evolution, such as the curriculum device. In this year, Korean curriculum was changed, revised, and this year, Korean curriculum was revised. So we think that, we suspect that maybe the trends, question activities and answering activities that relate to the situation of the curriculum change. And the other data shows that how many people have a question, made a question. Most of people, most people are over 75% of the questions received two or few replies, and less than 3% received 10 or more, excluding anonymous posters. Less than 1% of the users have written 6 or more questions or answers about evolution, and less than 1% of users have written more than 5 of total questions and 10 of total answers. So, what is the mean? We think that the result shows that some users and high activities and the trends in creating online activities about evolution suggest that online knowledge about evolution is likely to be heavily influenced by a small number of highly active users and anonymous authors. This is about related to the results or related to the meaning of the documents in the public online site. On the left side, sorry for the readability. On the left side, this document, this knowledge map, that map is derived from the scientific documents online. question and answer documents, and light is non-scientific posters. So the concept network analysis, as like a text network analysis, was conducted. Left map shows that the revolution is located in the center, and there are gene and mutation and Hardy-Weinberg equilibrium, like that. The evolution is leading scientific knowledge, scientific concepts for the making total meaning of the context. On the other hand, the light map of non-scientific maps, there are some concepts related to the religious beliefs, such as Bible and God and Genesis. So it informed that there's relationship network around these concepts, contrasts such as evolution and creation was identified in the meaning of the networks, as well as the relationship indication or the objective worldview based on the human thinking. The appearance of the concepts such as a textbook suggests that these documents are related to the creationistic arguments. Then we extracted the keywords of the scientific documents and non-scientific documents. So then we can use this keyword as the features for the AI model classification. So this shows the plotting of the PCA results. The vertical axis, there are located the scientific document dots, and the horizontal axis, there are non-scientific documents. And this is the 10% document. And then we train this model by these data, and next we apply it to the all data set. And it shows that there is a separation of the scientific document and non-scientific documents. So we think that it maybe can be used as the non-supervised models tool to distinguish the document types online. So I skip the discussion. From the research, we had three conclusions. First, the number of online posts related to the evolution has recently shown fluctuations, with 5 and 10% of posts contain non-scientific beliefs, depending on the period. And a small number of highly active or anonymous users can significantly influence the public perception of evolution through the question and answer system. It seems that it is necessary to continue monitoring the generation of relevant knowledge online. And the second, the conceptual network of documents related to evolution was visualized and analyzed to compare those containing non-scientific knowledge based on religions. Believed with these containing scientific explanations. The analysis revealed the significant difference in the structure and conceptual organization of the two networks, meaning networks, semantic networks. So, replacing the concept that formed the non-scientific understanding of evolution and developing educational measures to promote correct understanding of the topic should be continued and necessary. Last, we explored the possibility of the information of the processing the technology such as data mining, natural language processing, and machine learning can be effectively used as a classifying knowledge in the online documents and specifically related to the scientific topics. These outcomes can be lost tools for the filtering the learning materials to provide learners with a reliable scientific knowledge and for building artificial intelligence system that can continuously and automatically assess
Thank you very much. Humans, evolution. Very, very, very always question and problem too. Scientific and unscientific approach. Are there any questions, please? That's interesting that next report will continue problems of humanity. Communization, decommunization, and evolution, and so on and so on. If there are no questions now, maybe there are questions later on, private questions. Thank you very much. It was very, very interesting. And these elements of artificial intellect, but let's be very, very careful. Artificial intelligence, these are programs made with mathematicians, yes, and clever people. But nevertheless, human beings are much more complex. Yeah, you all know this very good.
So I will somehow continue with Angela's word. She mentioned three main words that mean learning, sharing, and growing. I will add one additional word, that is to draw. And I will also continue a little bit the colleague with Korea about evolution. I will give a little bit the new meaning of evolution. We will talking a little bit about transformation. Evolution is something smooth, and in some situation there are coming something like a storm, chaos, whatever, when we can make the bigger changes. So few words about the content. I will give some basic definition. I will talk about education from 20th and 21st century. I somehow, Vincent has learned me that it's not proper to use the word traditional education, or so I mentioned then 20th century education, and that's what we are doing today, some innovative way of education. I will talk something about, very short, about the society 5.0, 5.0. We're talking about super smart society, then the philosophy and art development. I will show some, very briefly, our research, what we are doing, from some conclusion, of course. So, three main words from the title. One is transformation, the second is dehumanization, and the third is rehumanization. So, if we